Did you know the way we create software has completely changed? And NVIDIA is leading this revolution? From coding to machine learning, from GPUs to the groundbreaking Blackwell system, NVIDIA's CEO reveals how they're redefining technology and shaping the future of AI. This is more than innovation. It's a glimpse into the future. Watch till the end to see how these advancements are impacting the world. If you're excited about cutting-edge tech, don't forget to like, share, and subscribe to AI Insight for more mind-blowing updates.
And I think it's very, very clear now the world has completely changed. Now let's think about what happened. The first thing that happened, of course, is how we do software. Our industry is underpinned by the method by which software is done. The way that software was done, call it software 1.0, programmers would code algorithms, we call functions, to run on a computer. And we would apply it to input information, to predict an output. Somebody would write Python or C or Fortran or Pascal or C++, code algorithms that run on a computer. You apply input to it, and output is produced. Very classically, the computer model that we understood quite well. And it, of course, created one of the largest industries in the world, right here in India, the production of software. Coding, programming became a whole industry. This all happened within our generation. However, that approach of developing software has been disrupted. It is now not coding, but machine learning. Using a computer to study the patterns and relationships of massive amounts of observed data to essentially learn from it the function that predicts it. And so we are essentially designing a universal function approximator using machines to learn the expected output that would produce such a function. And so going back and forth, this is software 1.0 with human coding to now software 2.0 using machine learning. Notice who is writing the software. The software is now written by the computer. And after you're done training the model, you inference the model. You then apply that function now as the input, that function, that large language model, that deep learning model, that computer vision model, speech understanding model, is now an input neural network that goes into the GPU that can now make a prediction given new input, unobserved input. This way of doing software, notice, is based on fundamentally machine learning. And we have gone from coding to machine learning, from developing software to creating artificial intelligence, and from software that prefers to run on CPUs to now neural networks that runs best on GPUs. This, at its core, is what happened to our industry in the last 10 years. We have now seen a complete reinvention of the computing stack. The whole technology stack has been reinvented. The hardware, the way that software is developed, and what software can do is now fundamentally different. We dedicated ourselves to advance this field. And so this is what we now build. What all of you have initially, when I first met India, we were building GPUs that fit into a PCI Express card that goes into your PC. This is what a GPU looks like today. This is Blackwell. Incredible system that is designed to study data at an enormous scale. Yeah, thank you. A massive system designed to study data at an enormous scale so that we could discover patterns and relationships and learn the meaning of the data. This is the great breakthrough. In the last several years, we have now learned the representation or the meaning of words and numbers and images and pixels and videos, chemicals, proteins, amino acids, fluid patterns, particle physics. We have now learned the meaning of so many different types of data. We have learned to represent, how to represent information in so many different modalities. Not only have we learned the meaning of it, we can translate it to another modality. So one great example, of course, is translating English to Hindi. Translating English, large body of text, into other English, summarization. From pixels to image recognition. From words to pixels, image generation. From images, videos, to words, captioning. From words to proteins used for drug discovery. From words to chemicals, discovering new compounds. From amino acids to proteins, understanding the structure of proteins. These fundamental ideas, essentially a universal translator of information from any modality to another modality, has led to a Cambrian explosion of the number of startups in the world. They're applying the basic method I just described. If I could do this and that, what else can I do? If I can do that and this, what else can I do? The number of applications has clearly exploded. In the last couple, 2-3 years, the number of generative AI companies around the world, tens of thousands, tens of billions of dollars have been invested in this field, all because of this one instrument that made it possible for us to study data at enormous scales. Well, I just want to say that in order to build the Blackwell system, of course the Blackwell GPU is involved, but it takes 7 other chips. TSMC manufacture all of these chips, and they're just doing an extraordinary job ramping the Blackwell system. This is Blackwell is in full production, and we're expecting to deliver in volume production in Q4. And so this is basically Blackwell. Now this is one of the things that's really incredible about the system. Let me show it to you. Oh, nothing's easy this morning. This is NVLink, and it goes across the entire back spine of a rack of GPUs. And these GPUs are all connected from the top to the bottom using NVLink, driving these incredible SerDes, the world's longest driving SerDes for copper. And it connects all of these GPUs together. 72 dual GPU packages of Blackwells, 144 GPUs, connected together so it's one giant GPU. If I were to spread out all of the chips to show you what this connects together, it's essentially a GPU so large, it'd be like this big. But it's obviously impossible to build GPUs that large, so we break it up into the smallest chunks we could, which is reticle limits and the most advanced technologies, and we connect it together using NVLink. This is NVLink backspine. You're looking at all of the GPUs being connected. That's the quantum switch that connects all of these GPUs together on top. Spectrum-X, if you would like to have Ethernet. And what connects this together, this is like 50 pounds. I'm just demonstrating how strong I am. This is connected to this switch. And this is one of the most advanced switches the world's ever built. Now, all of this together represents Blackwell, and then it runs the software that's on top. The CUDA software, cuDNN software, Megatron for training the large language models, TensorRT for doing the inference, TensorRT LLM for doing distributed multi-GPU inference for large language models. And then on top of that, we have 2 software stacks. One is NVIDIA AI Enterprise that I'll talk about in a second, and then the other is Omniverse. I'll talk about both of those in a second. This job is surprisingly rigorous. So this is the Blackwell system. This is what NVIDIA builds today.